The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so we're going to work through problem number 12. Problem number 12 for Physics 2020 Midterm Exam 1. And this problem says, an object has a constant acceleration of 5 meters per second squared. At a certain instant, its velocity is 100 meters per second. What is its velocity 2 seconds earlier? Okay, and so I've set up my coordinate system where we have the positive x direction in this way, positive y direction going that way, and a little illustration of the problem statement. So we've got an object, okay, and this is our object here, and its acceleration, they say, is constant, which is 5 meters per second squared, okay, and they're saying that at one instant, okay, sometime at time t, right, the velocity is 100 meters per second. And they said 2 seconds earlier, so we can write that as t minus 2, which is the time minus 2 seconds would be 2 seconds earlier. The velocity is undetermined. That's what we're trying to find, okay? So what we can do is think about, do we have enough information between the acceleration, velocity, and time to solve, to find out what the earlier velocity was 2 seconds earlier? And actually we do. If you look on your formula sheet for the Midterm Exam 1 2010, you'll see that since the velocity is constant, okay, that you can use under the acceleration, you'll see that it's defined as a change in velocity over the change in time, okay? And this is true for when the acceleration is constant, and we know that the change in velocity is going to be the final velocity minus the initial velocity, and the change in time is going to be the final time minus the initial time. All right? So we can substitute in the information where we have the final velocity, okay, which is at time t. Okay, so that's going to be 100 meters per second minus your initial velocity, which is at time t minus 2, which we don't know, we're trying to determine. And we know that the final time is t minus the initial time. The initial time is actually t minus 2. Okay? And so that's going to equal to our acceleration, which is 5 meters per second squared. All right? And we can do some simplifying of this equation now, where we have 100 meters per second minus the initial velocity, t minus a t, right? So the t's cancel out, and you're left with a minus minus, so that's just 2. And that's equal to 5 meters per second squared. All right? And now solving this equation for the initial velocity, we get we can get 2 times, and this is in seconds, okay? So we get 2 times 5 meters per second squared, and then we can get minus 100 meters per second is equal to negative velocity. So basically, we'll get the initial velocity is equal to 100 meters per second minus 10 meters per second. Okay, so all I did was solve this equation for your initial velocity, and since this has units of seconds, one of these seconds cancel out, so you're left with meters per second, and then this works out to be 90 meters per second, which is the answer. So all we simply did was use the equation for acceleration at constant velocity, which is the change in velocity over the change in time. We substituted the information that was given. We solved for the initial velocity, and that resulted in 100 meters per second minus your 10 meters per second, which gave us 90 meters per second.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.